Hello, this is Stephen, and this tutorial I will be telling you something about servo motors, how to control them and how to use them together with your Lego Mindstorms robot hub. We use the LMS-ESP32 to connect up to 4 servo motors. We have 4 connections possible because we also supply the ground and the 5-volt pins. You can hook a servo motor easily up by just using the standard header that comes with a servo motor, because this order is usually for all those motors the same. So we have different GPIO pins to control 4 different motors. And of course you could use these, but here the power supply and the ground is not available next to this GPIO as is in these 4 positions. So how does a servo motor operate? It is different from a normal DC motor in that it doesn't keeps turning around, but it's meant to move between two a minimum and a maximum angle, and that angle is determined by supplying a pulse width modulated signal. And the pulse width modulated signal is basically a square wave of a certain frequency, and it has a different duty cycle. The duty cycle is the percentage of time that the pulse is high related to the pulse low. So if I have a low duty cycle, it has just a small part of the time it's high, and a large duty cycle, a large part of the cycle is high. So if the servo motor, you can read that in the specification of the most servo motors, they have a typical frequency of 50 Hertz. So in between 2 pulses is typically 20 milliseconds, and they react in a range of 1 to 2 milliseconds to go from the minimum angle to the maximum angle. In the MicroPython that we are using, we have a PWM class that allows you to generate one of these PWM signals. So I can show you that by going to Tony, and in this Tony I can import a pin and a PMW classes from the machine library, and then I can say what I can show you here is I hooked up 2 different servo motors. The gray one is the Geek servo. It's connected to pin 21, and the blue one is one of these standard small servos, is hooked up to pin 23. And you see that I don't need to make any change on the cable, just could plug them in right away. So if I now define these 2 PWM pins, I can now say I can now set the duty cycle. The duty cycle is a typical value between 0 and 1024. So if you remember, it's 20 milliseconds between the pulses, and we have a range of about 1 to 2 milliseconds. So it's rather low here. So if I put 30, you see that this motor moves to its. If I even try smaller values, you won't see it move. If I increase the value, for instance 50, you see that it moves 70, and you will see that the maximum is about 130. I could calculate 130 divided by the maximum duty cycle times this 20 milliseconds, and I would get something about 2.5 milliseconds, and the minimum would be, this 30 would be 0.58. So between these 2 angles you will see that it reacts on. What you can see that is, if I choose the minimum value, it almost turns a whole rotation, 360 degrees. There's different with this blue motor that I have here. If I take the minimum value, I have to hold it a little bit so you can see it. It moves now to its lowest position. If I increase a little bit, you see that it increases 90, and if I put the maximum value, you see that it turned only 180 degrees. You see? So this is different. So this has different gear ratio to the output of the motor. That you have to keep track about that. To make things a little bit more simple, I use a library which is called servo.py, and what it basically does is it maps this PWM to different motor outputs, and it calculates based on a degree, on a number of degrees that you write to the object. It calculates this duty cycle, and it's easier to map an angle than to have a value between 30 and 130. So as an example, I can show you this. So I import the servo library. I define servo number 1 as the servo connected to pin 21. It has an angle of 360 degrees, as we saw, and it has a minimum and a maximum value of these values. That are the values that are calculated here. So if I define these 3 lines on the LMS-ESP32, I can now use the servo class to write an angle. If I write 0, it will be in position 0. If I write 90, it will be 90 degrees, 180, 270. If I would choose 360, it would be a complete turnaround, and it would be on 0, position 0 again. So I do 259, 359. So that's the maximum value. That's for this motor. If I do the second motor, I defined it here. That has a maximum angle of 180 degrees. So I have to choose my angle between these two values. So this is 0. I can do 45, 90, and the maximum is 180. So this maps in an easy way the angle to the position of the motor in a one-to-one relation. So now what I would like to show you now is how to control these motors, or one of these motors, from the Lego Mindstorms side. So I open a second Tony where I have the Lego Mindstorms present, and what I can do is I can load the UartRemote library, as I did in the tutorials before. You might see a little difference between the way I do it here. This is an extra directory, and that's because I use now the MPY robot tools, from which I import the UartRemote library. And in the other examples I use only the UartRemote library. So this MPY robot tools is a set of different libraries to control different things in your Lego robots, as with synchronization, Bluetooth, all this kind of things. I will give you a link on how to install this library on your Lego hub. So if I have imported this, I can now use the UartRemote library to communicate between the Lego Mindstorms and the LMS-ESP32. And before I do that, I made a small program. I can show you a little bit around. So what you see here, that is, I define the 4 pins. These are the pins that I showed you before on the pin out. This is 21, 22, 23, 25. And for each of these pins, I define a servo in an array, a servo motor object with the same definition as I used before. I made a mistake, I see here, because what I do need is to put pin there. Okay, so when this is okay, then I can define 2 functions. One is servo set angle. It takes the number of the servo. Keep in mind that it's numbering from 0, and an angle to which you set the servo, and it also keeps track of the angle as you defined it. So if you read later on the angle, you still know what angle the motor is. So I can use the get angle to get the position of the motor. I use UartRemote, and I add these two functions to the UartRemote command, and I end with a loop waiting for one of these commands. So let's run this. So this is waiting for a command, so let's see if this is working. I have to define the UartRemote instance. I connected the LMS-ESP32 to port A of the Lego Mindstorms, and now I can use call to call one of these two functions. So let's call servo set angle. I have to pass two variables. So I use the wrapper representation, and the first variable is the number of the motor, 0, and the second is the angle, let's say 90. So it moves now to 90, and now we can try to read the angle, and it says 90. So if I now move it to, let's say, 130, and I read it back, get angle, you see that's 130. So it keeps track of the angle that it has. So I can make a small program with that. That you see a little interactively how I can control this motor. So what I did is an endless loop on the Lego hub, where it keeps track of the press of the left or the right button was pressed here on the brick, and if I press one of it, decrease the angle or increase the angle. So let's run this program. So if I now increase or decrease, you see that the servo moves corresponding with the buttons I push. So this is an example of how to control a servo motor from the Lego Mindstorms environment. I hope you find this useful. I hope you can experiment now with some more low-level stuff. If you would like to do some more advanced stuff, I would advise you to have a look at the website of AntonMindstorms.com, where he builds a spider, and the spider is a Lego Mindstorms hub using the 4 standard motors and 4 of these G servo motors to have 4 legs with enough degrees of freedom to have a spider that really walks in a synchronized way. It's quite an advanced program that goes with it, but it's worthwhile to have a look at that as well. Bye.